In this video, we're going to look at solving systems of linear equations in three variables. Some key parts that you should know before we hop in is that we use the same methods that we used before, substitution and the addition method, or we also refer to that as elimination. Another thing you should know that is if we're dealing with three variables, we also should have three variables and three equations. Variables and three equations. Our answers for or solutions for a system of equations in three variables is not a coordinate pair, it would be a coordinate triple, since there are three variables instead of two. So an n-tuple is n numbers written in the form x1, x2, x3, so forth, so on until you get to n. So we could also think of this as a three-tuple or a three-tuple. However, we can just call it a coordinate triple. That will suffice. So let's jump in and start looking at some examples. The first thing we're going to do is we're going to check to see if a coordinate triple or an ordered triple is the solution to a system of equations. And so what we're going to have to do, just like we did with two variables, we have to substitute in the x, y, and z values into the three equations and determine if it satisfies all three equations, resulting in a true statement. So let's look at our example. Our example is we are determining if the ordered triple is a solution to the system below, which is these three equations. The ordered triple that we are provided is 0, -2, 5. So 0 is our x coordinate, -2 is our y, and 5 is our z. We take each of those values and substitute them into the three equations. So I'm going to do this first one. And we substitute in 0 for the x, -4 times our -2 is our y, plus our z, which is 5. Does that equal 13? Well, 0 is just 0, obviously. So I'm going to do -4 times -2, which is +8, plus 5. Does that equal 13? And then I get 13 equals 13. That is true. So it worked for the first equation. That's not enough to say that it's a solution to the system because we have to check all three equations. So I need to do the same thing for the second equation and the third equation. And we can only say it's a solution if it satisfies all three of them. So we have 3 times 0 plus -2 minus 5, does that equal -7? Well, 3 times 0 is 0, minus 2 minus 5, does that equal -7? Well, -7 equals -7. That worked for the second one. But again, we're not done until we've checked all three equations. So I'm going to do some side work up in a little cloud on the top right-hand side of the screen. 2 times 0 plus 3 times -2 plus 5, does that equal, my little question mark, -1? Well, 2 times 0 is 0, 3 times -2 is -6, plus 5, does that equal -1? -1 equals -1. Yes, it is a solution to that one as well. So therefore, 0, -2, 5, this ordered triple is a solution to the system. Now remember, in order for it to be a solution, it has to satisfy all three equations. If I have found out on the second equation that it didn't work for that one, but it did work, and solved and gave us a true statement in the first equation, but it didn't work for the second one, I can stop, because the second it fails to satisfy one of these equations, then it is not a solution. So if on the first equation it hadn't satisfied that first equation, we would be done. We can say, no, it does not work. Okay. But if you are proving that it is a solution, you have to show that it can be substituted in for the x, y, and z values for all three equations and give us a true statement. The process for solving a system of equations in three variables is kind of cumbersome. It's a long process. It takes a lot of work. This is not something you can do in your head. It's something that needs to be done on paper. So please make sure that you give yourself plenty of scratch paper to work out these problems. Here's what we end up doing. We want to choose a pair of the three, so two of the three equations, and eliminate one of the variables using the addition method. Okay, so that means you need to look at all three equations and find out which variable would be the easiest to eliminate based on two of those equations. Then you choose a different pair of equations and eliminate the same variable. Then you should have two equations that are in two variables, and then we would solve that just like a system of equations with two variables to get two of the solutions, two of the coordinates, and then we would plug those in at the end to solve for the third missing coordinate. So let's see how this works. It's a lot of talk until you see it. Okay, so we are given the three equations listed here. I need to determine which variable will be the easiest to eliminate. So what we want to look for is variables that have the same numerical coefficient but opposites of one another. So +3, -3 as coefficients, or -5, +5 as coefficients. So if you look here, the x is not a good idea because we have coefficients of 1, 3, and 2. For the y, we have -4, +1, +3 as coefficients. But and the z we have +1, -1, +1. So we have the same coefficient or opposites of each other as all of the coefficients for z. So on this one, I'm going to want to eliminate z. Okay, so I'm going to do that first with the first two equations. They're already opposites of one another, so I can just add the two equations together. Like so. X plus 3x equals 4x. -4y plus y equals -3y. Z plus -z is 0. It gets eliminated. 13 plus -7 equals 6. Okay, so that's our first step. We chose a pair of the two equations, these right here, and we eliminated z. Now we need to select another pair. So we used equation 1 and 2 here. So I either need to use 1 and 3 or 2 and 3. So I need to use a separate pair and eliminate the same variable. Okay, so I'm going to do these two equations. Eliminate z again. So we have 3x plus y minus z equals -7, and we have 2x plus 3y plus z equals -1. And again, we're going to add those two equations together to eliminate z. 3x plus 2x is 5x. Y plus 3y is equal to 4y. -z plus +z equals 0. They get eliminated. -7 plus -1 is -8. So now we have two equations in two variables. We can use substitution, or we can use the addition method to solve the system of two equations now. When we do that, we're going to get our x coordinate and our x value, and we'll get our y value, and then we can use that to plug into one of the original equations to solve for our z variable. So I'm going to do that on a blank sheet so you can see all the work and it doesn't get too convoluted. Okay, so we need to solve the system now of linear equations in two variables to find our x and our y. Since both of these equations are in standard form, I'm going to solve this using the addition method. Now what's tricky about this is that none of the coefficients are direct opposites of one another, and so therefore we're going to have to take an additional first step to get our coefficients to be opposites of one another. Now, when I look at this, I have a 4x and a 5x as so a 4 and a 5 as my coefficients for x, and a negative 3 and a positive 4 as my coefficients for y's. And so what I want to do is actually get the y's to have opposite coefficients towards of one another. And so what I just have to do is I have to multiply the first equation times 4 and the second equation times 3. So that gives us 16x minus 12y equals 24. And for the second equation, we get 15x plus 12y equals negative 24. And now I can solve this with the addition method. I can add those two equations together, and I end up getting 31x equals 0. So divide both sides by 31, and we get that x equals 0. So if x equals 0, we now can solve for y. So x equals 0. So to get our y, I'm going to substitute that into the first equation right here that I'm putting a star next to. So I get 4 times 0 minus 3y equals 6. Well, 4 times 0 is 0, so I get negative 3y equals 6. Divide both sides by negative 3, and we get y equals negative 2. So I know my x is 0. I now know my y is negative 2. Now I need to go back and solve for my z. So we have x equals 0, y equals negative 2. What is our z? And so what I'm going to do is I'm going to take my x and my y's and substitute them into any of these first three equations. This one, or this one. So I'm going to actually pick the one that will be the easiest for me, I think. And that's going to be the first one. I mean, you could use any of them. It should work no matter what you use, but I'm going to use that first one. So x minus 4y plus z equals 13. So my x is equal to 0, so I'm going to substitute in 0 minus 4 times negative 2, because my y is equal to negative 2, plus z equals 13. So I'm going to do negative 4 times negative 2, which gives me a positive 8, plus z equals 13. I can lose the 0 there because it's 0. I could just start from the negative 4 times negative 2. So I'm going to subtract 8 from both sides, and I get that z equals 5. So I have my ordered triple for my solution as 0, negative 2, and 5. Let's take a look. There's a method to the madness. We checked this problem already. That was our first problem. We got a solution in example 1. This is the process to how to solve and to get that solution. Okay, so if you wanted to check your answer, you would do the process that we did in the first example. I'm going to go ahead and stop this recording so that you can practice on your own. In the second video, we'll have examples, more examples that are worked out. Thank you.